Hello students, in this video I'm going to cover question number 13 of your EOT. In this we are going to talk about potential energy, system of pair of charge particles. So you should know about the electric field E, which is minus delta V over ds. You should know V is equals to K Q over R. You should know E is equals to K Q1 Q2 over R. Clear? These are the just basic equations you should know. Okay. Here is the energy. So K Q1 Q2 over R. There are some points. Work done is equals to positive. Work done must be done to bring them together from infinite and keep them motionless. These are the just points for your reading part, but the questions are in a different way. So we are going to focus on the questions first. Okay. This is something very good, huh? Very, very good question. In the figure, line represents equipotential lines. Okay, all the lines are equipotential. Fine. How does the magnitude of the electric field E at point P compares to the three cases? Compare to the three cases. So you just need to find out the gap. This has the maximum gap. Yes or no? The distance is the maximum. Here the distance is the minimum. Distance is the minimum. And here is the distance R2. So, or you can say just like R1, R2 and R3. R1, R2, R3. So can I say V is equals to K Q over R? Because what we are looking about, we are looking about the electric field. We are looking about the electric field, but the magnitude. Okay. So as we know, electric field is equals to K Q1 K Q over R square. You can solve like this also, or you can solve in terms of potential, because potential is given. V is equals to K Q over R. So can I say this term K Q over R multiply 1 over R? So you can place this value here. So you will get electric field is equals to V divided by R. Yes or no? So if the potential is higher, electric field is higher. And if the distance is low, electric field is high. Electric field is inversely proportional to R in terms of voltage. Yes or no? If distance is high, electric field is low. So you can see R1, R2, R3. So R3 is the maximum, E3 is the minimum. Clear? Okay, R2 is the minimum, E2 is the maximum. This is your minimum and this is in between. In between. Clear? So can I say what he is asking compared to the three cases? So E2 is the maximum, or you can say E3 is the minimum. Then you have E1 in the middle and E2 is the maximum. So this is your max and this is your min. So you have answer number is 3. Clear? Okay, now the next question. This is something which can create the problem in the mind also sometimes. So you need to be very careful while solving these types of questions. Calculate the electric field at point P. There are the 2 points are given which is relating to point P. This is your point P. Okay, here is 1 point and here is 1 point. Try to observe what is the value of the voltage here, 2000, and what is the value here, 0 volt. 0 volt. Okay, so what we need to do here, we need to find the electric field. We know E is equals to negative delta V over delta R. Yes or no? And we are finding what we are finding, the magnitude or just the value. So just solve it. Higher potential minus lower potential, higher potential minus lower, or just if you are using the negative, I'll tell you something, huh? Generally, what we say, delta V is V2 minus V1. If you say negative delta V, then what will happen? Negative V2 minus V1, then it will become V1 minus V2. So it will become initial minus final. Clear? So from where you are starting from? You are starting from 2000. So can I say 2000 minus, which is the 0, divide by what is the distance? That is the smart point you need to focus. Okay, so just create a line here, first line, and you can create a line here at this point. So you can take this distance. So 4.5 to 6, can I say 1.5, and this is given in centimeter. Then solve this. 2000 centimeter to meter, 1.5 times 10 raised to power negative 2. Solve this, you will get 1.5 or 1.3 multiply 10 raised to power 5 volt per meter. This is your electric field. Clear? This is a something, this is a type of question in which you need to focus that how to use magnitudes and how to use the direction, because here he is not asking about magnitude, not asking about magnitude. So if they are asking about magnitude, we need to use just the direct the values. No need to use the signs or anything, but you need to focus on these ones. Okay. Next question. Now, question number 3. In the figure, the line represents equipotential lines. Okay, all the lines are equipotential. What is the direction of electric field? Okay, as we know, what is the direction of electric field? Always from positive charge to negative charge. Yes or no? At point P. So it means this is at high potential. You can see the value is 30 volt. Here is the value is 5 volt. So here you have the positive charge. Here you have the negative charge. So electric field lines are going upward. Is it fine? Clear? So what is the direction at P? We can say upward. Clear? Okay. Next question. This is the interesting one. Three pairs of parallel plate have the same plate separation. Okay, focus on this point. Means the distance D is same. And the potential on each plate, potentials means we are looking about the V on each plate as indicated in the drawing. The electric field is uniform between each pair of plates and perpendicular to them. Rank the magnitude. Focus on this point. Magnitude between the plate from highest to lowest. Okay, so if we are solving this type of question, so I told you earlier, if you want to solve the magnitude, E is equals to negative delta V over delta R. Okay, so what you can do, I told you what will happen here, V1 minus V2 to make it normal. So you can say E is equals to V1 minus V2 over delta R. Clear? So R is same. So you just take higher and take the lower values and solve it. So 150 minus negative of 50. So your value is 200 volt. Okay. Take the second one. 200 minus of 20, which is equals to 220 volt. Okay. Third one, negative 500, negative 300. So it will become positive. So negative 500 plus 300, you get negative 200. But that the answer should be in modulus because we are looking for the magnitude. So answer is 200. So can I say E1 is equals to E3 E1 is equals to E3 and E2 is greater than E3. E2 is greater than E3. Yes or no? Okay, so 1 is greater? No. 3 is greater? No. The magnitudes for 3 and 2 are equal? No. The three magnitudes are equal? No. The magnitude for 2 is greater than 1 and 3, which are the same. Clear? Now you can solve your questions. Fine, guys? Okay, so till here, question number 13 is finished. I will meet you with the next question number 14. Till then, take care. Bye.